1 for college algebra. We're going to be talking about linear equations. So some basic terminology that you need to know. An equation is a statement that two expressions are equal. It doesn't have to be true. You can have an equation that's not true. Like I could write down 2 equals 7. That doesn't make 2 actually equal to 7, but it's still an equation. Here are some examples of equations. X plus 2 equals 9. 11x equals 5x plus 6x. X squared minus 2x minus 1 equals 0. When we say solve an equation, that means we are going to find all numbers that make the equation a true statement. These numbers are called solutions or roots of the equation. A number that is a solution of an equation is said to satisfy the equation. And their solutions of an equation make up what we call a solution set. Equations that have the same solution set are called equivalent equations. So here is an example of equivalent equations. X plus 1 equals 5 is equivalent to x equals 4 because if I subtract 1 from both sides, I get x equals 4. And 6x plus 3 equals 27. These are all equivalent equations. Something happened to my copy and parts of it got cut off, so yours will be better than this. This is an equivalent equation because if I subtract 3 from both sides, I get 6x equals 24, and then divide both sides by 6. I also get x equals 4. So all 3 of those are equivalent equations. They have the same solution set, which is that set of 4. X squared equals 9 and x equals 3 are not equivalent equations. The reason for that is that x squared equals 9 has 2 solutions, so its solution set is negative 3 and 3. Which is not the same as x equals 3 because that solution set is just 3. There are some legal moves that we can follow when we are solving equations. We can add or subtract the same value on both sides, like we did on these 2 equations. We can multiply or divide both sides by the same non-zero value, like we did here, divide by 6. And then on this one, we can raise both sides to the same power, which includes rational exponents. Remember that rational exponents are radicals, basically. So on this one, what I did to solve is take the square root of both sides, which gave me 2 values, because every non-zero number has 2 roots, a positive root and a negative root, which is why we got those 2 values. Okay, let's move on and talk specifically about linear equations, because that's what this section is about. A linear equation in one variable can be written in the form ax plus b equals 0. That doesn't mean it's written that way to start with, but it can be written in that way. A and b must both be real numbers. So remember that real numbers would include decimals, fractions, radicals, positive numbers, negative numbers, all of those included in real numbers. And it's called a first degree equation because the exponent on the variable is a 1. So here are some examples of linear equations. Notice that they are all either in this form or can be written in that form. So ax plus b equals 0 is already like that. 3/4 x equals 12. If I subtract the 12 over, it would be 3/4 x minus 12 equals 0. So it's in that form. And then this one, if I distribute the 0.5 and then move all my terms to the same side, I can rearrange it into that form. These ones are not linear equations. We call them nonlinear equations because on this one, the degree is not 1, it is 1/2 because, well, I guess I'll just write 1/2 here, because the square root of x can be written as x to the 1/2. On this one, the degree is not 1, because remember that when we have a reciprocal, that means we had a negative exponent. So this is x to the negative 1, that degree is not 1. And then on this one, the degree is 2, because when we're looking at a polynomial, we want the highest term to be the degree of that polynomial. So these are nonlinear. Let's practice solving a linear equation. You've been doing this for forever. Each time you solve a linear equation, the steps are going to be slightly different because all equations, have different stuff in them. This particular equation, I see that I am going to be distributing a 3 on this side. And then on the right side, I have 7 subtract x plus 5. Well, this is like an invisible negative 1 times, so I'm basically going to be distributing negative 1 to both of those terms. So on my next step, I would have 6x minus 12 equals 7 minus x minus 5. Now to solve a linear equation, what I want to get is all my variables on one side and all my numbers on the other. So that's kind of the goal of where we're headed. So we want variables on one side, and that's really only going to be one variable because it's a linear equation. It has only that x in it, and then constant terms on the other. So after I've done that distributing, I'm going to go ahead and move my variable terms to one side, my constant terms to the other. I prefer to work with positive coefficients, so I'm going to choose to add x to both sides, which will give me 6x on the left side. And then I'm going to add 12 on the other side. So then I have 7 minus 5 plus 12. I'll combine all of those things together. So now I have 6x equals 14. And then I'm going to need, I think I added something wrong. Yeah, 6x plus x is 7x. This is what happens when I don't have people around telling me my mistakes. So I have 7x equals 14. And then I will divide both sides by 7, and I will get x equals 2. So if they're asking me to write that in a solution set, the solution set here would just be that curly brace and then the number 2. I don't need a comma because there's only one number. So that's our solution set. Let's solve a linear equation with fractions. So I know that we'd rather not deal with having fractions in our problem. Good news, we can actually clear the fractions. What we are going to do is multiply each term by the LCD over 1. So anytime you are working with an equation that has fractions, this is my go-to strategy. To figure out the LCD, I'm going to write each of my denominators in its factored form, and I'm going to stack those common factors above each other. So I have a denominator of 3, another denominator of 2, and then 4 would break down to 2 times 2, 2 times 2, and then I have another 3 for a denominator. So as I'm figuring out that LCD, I'm going to bring down 3 times 2 times 2, and that makes my LCD, what, 12? Okay. One strategy that I like to use, though, is to keep it as 3 times 2 times 2, but if you want to keep it as 12, that's up to you. So I'm going to take each of those terms, 2x plus 4 over 3, and I am going to multiply them by the LCD, 2 times 3 over 1. and then I have plus. Now this 1/2 x really means 1 over 2 times x over 1. So I'm going to go ahead and put that x into the numerator because 1/2 times x over 1 becomes x over 2. So this is going to be x over 2, and I'll multiply that by that LCD, 2 times 2 times 3 over 1. And then equals, I'll do the same thing here, so that makes it x over 4 that I'm multiplying by the LCD over 1. And then I have subtraction, 7/3 that I will multiply by 2 times 2 times 3 over 1. And then I'm going to go ahead and cancel anything that I legally can. So in this first term, I'm going to cancel this 3 with that 3. And that's going to leave me 2 times 2, which will be 4. And then I'll go ahead and put that numerator inside its understood parentheses. Remember, those exist. So it'll be 4 and then times 2x plus 4. In my second term, I can cancel off a 2. And I'm going to be left with x times 6 equals, in this term, the 4 cancels with 2 times 2. And I'm going to have 3 times x minus, in this last term, the 3's cancel, and I have 7 times 4. Now I'm back to just my instructions from the first page, which are to solve this equation by getting all the variables to one side, constant terms to the other. So I will distribute 4, so 4 times, which is going to be 8x plus 16, and then x times 6 is 6x, equals 3x and then minus 28. So remember I said I like to have my coefficients be positive, so I'm going to go ahead and subtract the 3x from both sides. And while I'm at it, I'm going to combine it with the 8x and the 6x. So 8x and 6x subtract 3x is going to be 11x. Then I'm going to subtract 16 from both sides. And when I combine negative 28 and negative 16, I get negative 44. So 11x equals negative 44. Divide both sides by 11. And we get x equals negative 4. So the solution set there is just that single value, negative 4. Okay, let's talk about some types of equations. We can have 3 types of equations with linear equations. We can have what's called an identity, a conditional equation, and a contradiction. In an identity, what you're going to see happen if I distribute this 3 so that I get 3x plus 3 equals 3x plus 3. Notice that that is exactly the same on both sides. If I start moving my variables to one side and my numbers to the other, what you're going to see is that you end up eventually with 0 equals 0. So the thing about an identity is that it is always true. So when we have an identity, identities are always true. When you solve an identity equation, you're going to end up with the same number equaling itself. So you're going to get the same number on both sides. On this one, I ended with 0 equals 0, but I could have stopped ahead of that and ended up with negative 3 equals negative 3 or positive 3 equals positive 3, but it's going to end up being the exact same on both sides. The solution set for an identity is going to be all real numbers. So the way that we would write that is we would put like the curly braces, and then we just put all real numbers inside that. Well, this pen is going to die. Okay. Here is a conditional equation. Conditional equations are like the ones that we've just solved in the first two examples. Conditional equations are sometimes true. When you solve a conditional equation, you're going to end up with something that looks like x equals a number. So in this example we have here, if we divide both sides by 2, we get x equals 2. And in this case, the solution set would be the number that we get. So in this case, it's 2, but in general, it's just going to be whatever number you got when you solved for the variable. And then we have something that is called a contradiction. A contradiction is never true. That's why it's called a contradiction. In a contradiction, you're going to get some number, but it's going to be equal to a different number. So in this case, I have x equals x plus 1. When I subtract x from both sides to get all of the variables on one side and constants on the other, I end up with 0 on the left and 1 on the right, which we can see is not true. The solution set for a contradiction is the empty set. And remember that we don't put that empty set symbol inside the brackets, the curly brackets, we just write it as empty set. So let's identify if we have an identity, conditional equation, or contradiction, and then give the solution set. So on A, I am going to distribute that -2 on the left side here, just to these two terms. The parenthesis tells me to stop there. So I've got -2x minus 8 plus 3x equals x minus 8. I might go ahead and combine these like terms here. So I get x minus 8 equals x minus 8. Okay, at this point I can see both of these sides are the same. So this is going to be an identity. I could take it further, and I could subtract x from both sides to where I get -8 equals -8. And I see that it's an identity. I could even go a step further and add 8 to both sides, so I get 0 equals 0. But all the way up here, at this step, I could see it's an identity. So this one is an identity, and the solution set is all real numbers. Letter B. I'm going to start this one by adding 4 to both sides so that I get all the variables on the left side, 5x, all the constants on the right, 15. Then divide both sides by 5, so we get x equals 3. This one is sometimes true. This equation is true only when x is 3, so it is a conditional equation. And the solution set is the number 3, because that's the only time that it's true. And then my third equation here, I will start by distributing 3 to both terms. And I'm going to get 3x minus 3 equals 9x plus 7. I am going to move my 3x to the right side because I really like my coefficients to be positive, if possible. So I'll have 6x on the right, and then subtract 7. Oopsies. Y'all, this is 9x. 9x. So I'm going to have 0x on the right side, which is the same thing as just 0. And then when I subtract 7 from both sides, I get negative 10 on the left side. So now I have negative 10 equals 0. That is false. That is a contradiction. Contradiction. So the solution set to that one is empty set. Okay, solving for a specified variable. These are called literal equations. And they tend to be somewhat challenging. They're just different every single time you do one. And it's just, I think it's more challenging because when you're finished, you're not going to have an answer like we did before. Like you're not going to get x equals a number. It's just going to still have a whole bunch of variables in the answer. It's just basically like rearranging a formula to get a different letter by itself. So let's look at this first one. I equals p times r times t. So what they want us to solve for is the letter t. So they're wanting us to get t equals when it's all said and done. So I equals p r t. Remember that when we have variables sitting next to each other like that, it means they're multiplied. So it might make it easier if you write the little dots in between them. And what I'm wanting is to have t by itself. So I have p times r times t right now. In order for me to have t isolated, I need to be dividing. Since I have two things that are multiplied, I'm going to go ahead and divide by both of those things at the same time. So I'm going to divide by p, which will cross off that p. I'm going to divide by r, which will cross off that r. But I have to do that on both sides. And that's basically all we have to do on this problem. The answer is going to be t is equal to I over p times r. That's it. Let's look at letter B. On letter B, we are supposed to be solving for p. Here's the problem. There are two terms with that variable that we need. So in this one, we're going to have a specific strategy that I'm going to share with you right down here. When there are two terms that have the variable you need, what you're going to want to do is you're going to move all the terms with that variable to the same side of the equal sign, and the rest of the terms to the other side. So that's my first job. I want everything that has a p in it on the same side, and every term that doesn't have a p in it on the other side. So I'm going to go ahead and add p to both sides so that my variable p is positive, and I'm going to have a equals p plus prt. Then the next thing I'm going to do is factor out the variable. So we're going to end up with the variable on the outside because it's a GCF, and then we're going to have other things inside a parenthesis. So on this one, I'm factoring out the letter P. If I factor out a letter P from the letter P, what do we have left in its place? It can't be empty. I have to have something there. Remember that factoring out is just like dividing. So basically, I'm going to do P divide by P, and that's going to leave a 1 in that spot. And then factoring p off of the term p times r times t is just going to leave me with r times t. Technically, I could have 1 times r times t, but I don't need that 1 here in the same way that I have to have this 1 right here. This one has to be here. There could be a 1, an optional 1 right there. So now I've factored out the variable like a GCF, and then the last thing I'm going to do is divide both sides by the parentheses. So I divide both sides of this equation by 1 plus RT, divide by 1 plus RT. On the right side, that allows me to cancel the 1 plus RT because it exactly matches. And now I have P by itself. P is equal to A over 1 plus RT. And that is the answer for this problem. Notice that there's only one P left. There's no P's on the right side. That means I have isolated P, or solved for P, which was what the direction said. All right, C. We are supposed to solve this one for x. So I have x's. 2 terms I have that variable, so I'm going to move all the terms with that variable to the same side, and then everything else to the other side, and see what happens. But this letter x is involved in like a multiplying situation. It's in parentheses with a 3 out front. So I'm actually going to go ahead and distribute that 3 into both of these terms here. And I'll have 6x minus 15a plus 4b equals 4x minus 2. And let's start moving all of our x's to the other side. So I will subtract 4x, subtract 4x, and then I want everything else that doesn't have an x to the other side. So add 15a to both sides, and subtract 4b from both sides. Let's see where we're at now. The 6x minus 4x, I get 2x. These terms are gone, so 2x equals 4x minus 4x, that's gone. I have negative 2 plus 15a minus 4b. Okay, I'm really quite close, but I don't have x by itself yet. I didn't even have to do a GCF thing because the x's kind of worked out nicely on their own. So I'm just going to divide both sides by 2. And I will actually just leave it like that. So I'm going to leave this as x equals negative 2 plus 15a minus 4b all over 2. And that's just going to be my answer for this problem. All right, this formula up here, letter A, is actually the simple interest formula, and we're going to work with that here in example 5. You will have some story problems that have formulas, but it's really nothing, like, don't be nervous about it, because when you have a formula, you really just have to figure out the information that you're given, substitute it into the correct spaces, and then work out your problem. So I'm not super loving that they used x's here. I wish that they were dots instead, but they are x's, so they just mean multiply. Maybe I'll just turn them into dots. Times, they're just really big dots. Times, okay. And let's talk about what each thing is. I is the interest that will need to be paid. So you're borrowing money or lending money, and they have to pay back the amount they borrowed plus interest. So that's that. P is the principal, or the amount borrowed. R is the interest rate, or rate of interest. The thing about the rate of interest is that it has to be in decimal form. So when we have 4.5%, we can't use 4.5% in our calculations. We have to turn that into a decimal by moving the decimal point 2 places to the left, filling in spaces with zeros. So we will make that 0.045. So be sure you're making that change. And then T is the amount of time that's passed, but it's usually in years. So on this problem, we're going to have to make a change. So a woman has borrowed $5,240 for new furniture. She will pay it off in 11 months at an annual simple interest rate of 4.5%. How much interest will she pay? So the amount of interest she's going to pay is found by taking the principal times the rate times the time. The interest is the thing we're trying to find, so it is going to stay a letter. So it's asking how much interest, so that's what we don't know. We do know the principal, or amount borrowed, that's this. So P is 5,240. They give us an interest rate of 4.5%. So we're going to convert that into 0.045, and we'll use that for our interest rate. And then time is supposed to be in years, but they have given us 11 months. So we're going to take our 11 months and we're going to turn it into years. Okay, to do that, I know that 1 year is equal to 12 months. So I just take my 11 months and multiply that by the conversion factor. Since I want months to cancel, I'll put months in the denominator, years in the numerator. So it's going to be 1 year over 12 months. Then my months cancel, I multiply straight across, and I get 11 over 12 years. So for my time, I'm going to be using 11 over 12. Alright, then we're just going to work through. So I have I equals P, which was 5,240, times R, which was 0.045, times T, which was 11 twelfths. This is going to be money, so we're definitely allowed to use decimal points on here. So we're just going to do, we'll get out our calculator. I don't have my calculator handy, so I'm going to use the calculator app on my phone. So I will take, gosh, where's my numbers? 5,240 times 0.045 times 11 twelfths, and that is going to give me 216.15. So that is the amount of interest. I equals 216.45. So she pays $216.45 in interest. Now, that's not the entire amount that she's going to be paying back. We could figure that out, though. Altogether, she will pay back she has to pay back the 5,240 plus the interest of 216.45. So I'm going to have to add that to her 5,240. And that's going to be $5,456.15. Okay, good luck with your My Math Lab.